Good evening, everybody. How are you? Welcome. My name is Jeff Sabo. I'm the Chief Executive Officer of the Suffolk County Water Authority. We appreciate you coming out on this rainy winter evening to learn a little bit more about drinking water and the Suffolk County Water Authority and all the good stuff we do. I'm joined by some of our top staff. We have with us Chris Niebling, who's our Deputy Director for our Laboratory Services, Ty Fuller, who's our Director of Strategic Initiatives, and Tim Kilcommons, who's our Chief Engineer and our Director of Research and Development. So I'm going to give a little bit of a presentation here, and then each of us will cover a portion of it, and then we'll answer some of the questions you have about the Water Authority and what we do. So why WaterTalk? What is WaterTalk? There's a lot of information out there about drinking water and drinking water quality. A lot of it can be pretty confusing. So we started WaterTalk about 3, 4, maybe 4 or 5 years ago, holding these events every other month across Suffolk County to meet with individuals like yourselves to educate them a little bit about their drinking water. You're going to hear from some of our experts, as I mentioned. We're going to talk about the laboratory and also mention some steps that you can take to make sure that you're protecting and preserving drinking water here in Suffolk County. One of the things that we try to do with these meetings is to talk a little bit about the specific infrastructure and drinking water quality in your neighborhood, right? In this community, we don't look at it Suffolk County wide. We sort of drill down as much as possible and give you as specific information as we can. We'll also talk to you about a program that we started about 8 years ago that will allow you to pull up information about the specific drinking water quality in your home or that goes to your home. And then, as I mentioned, most importantly, we'll answer some questions about Suffolk County Water Authority and what we test for and how well we do it. So we want to talk a little bit about what Suffolk County Water Authority, who we are and what we do. We're an independent public benefit corporation, right? We operate under public authorities law, New York State. We serve about 1.2 Suffolk County residents. That's about 80% of the population in all of Suffolk County. We began operations in 1951, and we act as a not-for-profit. So we have no taxing ability. All of our revenues are generated through the sale of water. We're also one of the largest groundwater suppliers in the entire United States. Believe it or not, pretty unique. We are not a branch of Suffolk County government, right? Often just because of our name, people think that we are a division or a branch of the county itself. We're independent of the county. The Water Authority does not create or enforce drinking water regulations. This is the responsibility of the Environmental Protection Agency and the New York State Department of Health. And with that, I'm going to turn it over to Christopher Niebling, our laboratory. He was manager. We just promoted him to deputy director. So congratulations. Hi, Chris. Come on up.
Good evening, everybody. My name is Chris Niebling. Just a quick background on myself. I've been here at the Water Authority for 29 years, all of which have been in the laboratory. I started as a chemist and worked my way up the ranks. Just want to talk a little bit about our laboratory. A lot of people don't even realize it exists. In this first slide here, which I kind of like to brag about, we're one of the largest, most advanced groundwater drinking laboratory in the country, hands down. We have a staff of 51 employees, from chemists to bacteriologists, to lab technicians, to IT support, as well as administrative staff. We do a lot of sampling here at the Water Authority. We have close to 600 active wells throughout our distribution system. And we take samples from various stages of treatment. We test the raw water that comes directly out of the ground because we want to know what we're dealing with up front. If there's some sort of filtration system at a particular well field, and I'll explain a little bit more in a further slide what that is, we'll test just before the filter and directly after the filter. We also test what's called treated water. Okay, our water is naturally acidic, so we add hydrated lime to adjust the pH. Okay, very simple pH test is very important. We want to have that pH between 7 and 8.5, and basically what that does, it's our corrosion control that prevents any Flint, Michigan type issues where the aggressive water could start to leach away at some of your plumbing and pipes. You could have some elevated lead issues. But that's one of the things that we do add to the water is hydrated lime. We also add chlorine to disinfect. Trace amounts of chlorine are added to the water. We do not want to have any sort of E. coli type outbreaks in our distribution system. Lastly, we test what we call our distribution system. There's a future slide I will show you. We have roughly over 300 of these sample stations that are kind of blended in your neighborhoods. They're around industrial parks, kind of spread out evenly throughout our distribution system. And our sample techs go there on a daily basis and take samples, and we do the testing when we get back to the laboratory. Some of the compounds that we look for is it's a wide range of inorganic and organic chemicals, from just your basic metals that you find that are naturally occurring, like calcium, magnesium, potassium, to things that are more man-made, dry cleaning solvents, degreasers, things of that nature we look for. And here are some numbers. This here is our 2021 published data. So the lab analyzed 91,251 samples in 2021, which accounted for almost 191,000 tests. All right. Bear with me. What did I do wrong? Is it good? Oh, now I gotta go back. Okay, here we look for 414 compounds in 2021, which is 265 more than what our regulator requires us to do. Each year, the Suffolk County Department of Health Service will send us a list of compounds that we need to look for. We abide by that, as you can see, and we're testing for a lot more on a daily basis. We also test at a higher frequency. Part of that report that comes to us from the health department, it gives us our minimum monitoring requirements. At bare minimum, we're going to go to a well and test it at least twice a year. If it's negative, we'll go there quarterly if it's positive. Even some cases, if we feel that we have to go, we will go weekly and do testing at any particular well. And last but not least, our in-house standards for water quality are far more tougher than what state and federal regulations require. In the future slide, I'll explain a little bit more about that. Levels of detection. Okay, always like to explain this because, you know, when you're looking at lab reports, you're going to see things like parts per million, parts per billion, parts per trillion. Sometimes it really gets a little bit confusing. When I first started, everything was in parts per million, 29 years ago. As technology has gotten more advanced, the instrumentation has gotten more sensitive, we moved on to parts per billion, or we call micrograms per liter. To right now, we're even at parts per trillion or nanograms per liter, very, very trace amounts. And just to give you a reference point, 1 part per million is equal to 1 second in 12 days. 1 part per billion is 1 second in 32 years. And 1 part per trillion is 1 second in 32,000 years. And just another reference point on parts per trillion, a grain of sugar in an Olympic-sized swimming pool, if you want to put that in perspective. Okay, very trace levels. Getting back to our sampling, this is an example of a sample station. Like I said, we have over 300 of these located throughout our distribution system. This is one of our sample techs. We're required to go there on a weekly, daily basis. We have to collect close to 1,000 bacteriological samples, okay, every month. That is a requirement. Twice a year, we go there and do the complete set of testing. We kind of want to know what's in your distribution system. It's more representative of what's going to your home. Excuse me. Oh, I'm sorry. Yeah, these are basically green boxes, if you start to look around on the side of the streets, you will see them. There's locks on them. But like I mentioned, we're there almost every day collecting at these sites. Okay, back to the original statement that I said, if a well is on filtration, this would be an example here of what's called a granular activated carbon filtration system. Basically a Brita filter on a grand scale. Okay, inside these filters are a carbon media. We use two different types. We use a bituminous coal-based carbon, specific for certain contaminants. And we also use a coconut-based carbon. That's more specific towards your volatile organic contaminants, gasoline derivatives, things like that. But what I want to get back to with this slide here, like I mentioned earlier, our standards in-house are stricter. Okay. And I'll give you an example of a particular, say, volatile organic contaminant, say like a degreasing solvent. Okay. The maximum contaminant level that we can serve to our customer is 5 parts per billion. Okay. There's that parts per billion again. Okay. We won't let that sample go above half the MCL, or say 2.5. In most cases, we're changing out less than 2 parts per billion. Okay, but meanwhile, our regulators state that we can now supply that water up until 4.999 micrograms per liter. We want to be very proactive with this. And the process basically, and all of us are kind of guilty of this, our filters on our refrigerators, we forget to change them out. Okay, over time, bacteria can build up in there. The contaminants, if any, could start to now what we call break through. Okay, like with anything, that carbon now becomes spent. Okay, that's why we're going to these sites, these wells that are on filter, and doing quite a bit of testing to monitor to see where that breakthrough is occurring. Once it breaks through, we take that well out of service. Okay, our vendor comes in, they take the old carbon out, they put the new in, we do some testing. If it meets specs, we start the process all over again. Okay, and then, depending on how much water flow is, depending on how much, carbon, will change out at a particular site. This slide here is our consumer confidence report. Every year at the end of May, we're required to put out this particular report. It's about a 50-page document, has a lot of useful information in there, and it has all of the water quality data, okay, that we sampled during the course of that year is in this report. Now, this particular report is the treated water. That's the water is being supplied to our customer. Okay, so when you look at this, you go through it. Okay, Ty actually made a nice interactive map here. You can go onto our website, type in your address. It'll bring you to your particular area. Okay, and then you can kind of glance through the data. When you're looking at the data, you're going to see a low, a high, and an average. What you want to kind of focus on is more or less the average number for that particular compound or contaminant, when you're looking at this data. The other report that we have to supply is called the supplemental report. That is the raw water, untreated, that comes directly out of the ground. And we tend to keep between 5 and 6 years on our website. So if you want to compare over the years, it's up there. And my last slide here, emerging contaminants. These are the ones that make the news. These are your hot topics of late. Specifically, in our case, it's called PFAS contaminants. These are perfluorinated alkyl substances. They're found in firefighting foams, microwave popcorn bags, Burger King wrappers, old pots and pans, Teflon tape, things of that nature. We've kind of been rolling around PFAS compounds for many, many years. Instrumentation is finally caught up. We're now able to see down to these very trace levels, getting back to parts per trillion for some of these contaminants. But the good thing is that bituminous carbon does a great job at filtering out any sort of contaminants that could be, in a particular well that we have. The other one, emerging contaminant here is 1,4-dioxane. 1,4-dioxane is found in one of those degreasing solvents, 1,1,1-trichloroethane. It's also found in some of your household products, shampoos, detergents, makeup, things like that. This one is a tricky one to filter out, and our chief engineer is going to explain a little bit how we, approach that particular contaminant. But also here, every quarter, we're required to put our data out there. So there's a quarterly update of the 1,4-dioxane and the PFAS compounds that are up there. Every month, Tim Kilcommons, our chief engineer, goes through some of the projects that are in the mix. What type of filtration is being installed, where we're at in terms of that project. And there's also some useful information about public health and things of that nature. But with that being said, I'd like to turn it over to Mr. Tim Kilcommons, our chief engineer.
Thanks, Rick. Is it the enter button to advance or arrows? The arrows? Okay, thank you. Good evening, everybody. As Chris said, my name is Tim Kilcommons. I'm Chief Engineer, Director of Research and Development at the Water Authority. I've been with the authority for 22 years now. I started out as pipeline superintendent in charge of the water main construction, advanced to Director of Construction Maintenance Department, the department responsible for the design, construction, and maintenance of the distribution system at the authority, and now been Chief Engineer, I think, my God, it's been 12 years now. Yeah. Over in the engineering department. The engineering department at the Water Authority is a bit unique in terms of Long Island water suppliers. We're big enough to have our own in-house engineering department. We do all the design and construction of the water supply infrastructure. So drilling of the wells, the treatment that gets put into place, the storage tanks that are built, and we help out as well with facilities, doing things like CNG fueling facilities, maintenance facilities, warehouses, and things like that for the authority. A few statistics about our infrastructure. 633 total wells at approximately 240 pump stations. So very spread out throughout our service territory, decentralized supply, which is great for redundancy, for reliability. We have 68 storage tanks, 71.6 million gallons of storage at any given time. As engineers, we love that. Water you have in hand is much better than water you have to get out of the ground, because on Long Island, remember, we don't have surface reservoirs. We don't have lakes that are supplying our water. Every drop of water we take, we need to power it up and out of the ground to get to it. So anytime you can have it up above you, that's water that can be used in an emergency where maybe you don't have power. Average daily pumpage, 210 million gallons per day in our system. Peak pumpage, you see how much higher that is at 470 million gallons. That's your irrigation in the summertime. That's people's doing their sprinkler systems. And more recently, we're seeing the effects of geothermal systems, large geothermal systems that add to that disparity. And then part of what we do, besides serving safe water for our own consumption and irrigation purposes, is fire protection. Big part of what we do. 37,000 plus hydrants in the system that we make sure have adequate flow to them, and we maintain them. Generally, our construction maintenance department keeps those hydrants. The American Water Works Association, kind of the industry trade group, gold standard, says we should be doing inspections once a year. We're on about a 10-month cycle with our hydrant inspections. Okay, so here's a shot of just exactly how spread out we are. So basically on the South Shore from Amityville to the tip of Montauk at Camp Hero, North Shore from Huntington all the way out to Orient. All those pump stations, the stars on this map are denoting administrative facilities. So in Huntington here, we have a construction maintenance office where our crews shape up each morning for work around here. Allows us to respond faster to things like water main breaks, and makes the crews more efficient too. They're not spending half the day on the road. Okay, so source water. What I like about this slide, showing basically a slice of the island. Takeaway here, we all know by now where we get our water from, right? It's precipitation. We have rain, you have snow events. USGS tells us on Long Island, we lose about 50% of what falls from the sky. We lose it to evaporation, we lose it to runoff. It's heading out to streams, it's heading out to the sound, it's heading to the ocean, to the bays. So we are getting about half of it. But what's interesting about this slide, what I like about it, is that it also kind of gives you an idea of how things that are hitting the ground besides the water, contaminants, right? That go on the ground, spilled on the ground, go into the ground, how those are also impacting the groundwater. And so you can see here in the lower right hand, we have two wells. We have a deeper well and a shallow well. We have a service station in the upper right. So obviously we have a buried tank there, potential source of contamination. We have a cluster of homes, all with septics, another source of potential contamination. And then we have a farm field that looks pretty far away from the wells. Stuck again. Oh, there we go. And back. Okay, so what I wanted to demonstrate here was for a shallow well, a lot of people would think your perception would be that if you have a well in an area, that the immediate area is what you need to be concerned about in terms of what could possibly contaminate your well water. And for a shallow well, that can be true. So the shallow well you can see here, it's grabbing water that's coming through from the aquifer, and also getting whatever runoff is coming out of these septics is getting pulled towards the shallow well. The deeper well that you see right next to it, it's a little further away, is actually more at risk in this slide from the farm field, where maybe you're getting herbicides, pesticides, things like that on it. So it just goes to show you there's a lot. There's the geology itself, what's happening in the aquifer. There's how deep the well is. And then there's the travel time and the natural groundwater flows in the aquifer that all contribute to that. And we have models. Ty's group has a model where we can actually figure out if we drop a particle here, where will it be? And how long will it take to get to our well? So we can kind of gauge those things. So as far as local infrastructure, the well fields are circled in magenta and tanks. The distribution sample stations that Chris was talking about earlier, showed the picture of, those are represented by the green dots here. So you can see it's pretty well represented on what we have. And then if you go back to the slide that I just showed you about how the water is coming to the well, what you have here, these kind of blue clouds, are what we call source water or contribution areas for the wells. Contribution areas for the wells. And what it's telling us is, for instance, up here we have Flower Hill Road. Flower Hill Road is right next to a golf course. And you might think right away, okay, the golf course, you got fertilizers and things you need to worry about. The actual contribution zones for Flower Hill is much further south. And it's actually down here like a 25 and a 50-year capture zone. And those are the types of things that we look at and that we model. And that's not to say we wouldn't be concerned about what's happening here, because it can affect other wells in the area. So when Chris talked about emerging contaminants before, he talked a little about the perfluorinated compounds. We also had the 1,4-dioxane that he spoke about. The treatment that we use for that is different than perfluorinated. Perfluorinated compounds get treated with a treatment that's well understood by us, that GAC, that granular activated carbon system that Chris pointed out before. 1,4-dioxane is not very well removed at all by GAC. Each of those vessels that Chris showed you before, those green vessels, those contain, he called it a glorified Brita filter, which it is, except each of those vessels contains 20,000 pounds of carbon. It costs approximately $60,000 to change out the carbon on one of those systems. One system consists of 2 vessels. When we treat for a perfluorinated compound, it's dependent on flow, but a general rule of thumb is we would expect to change it out about once a year. So you incur that cost about once a year. When you use GAC for 1,4-dioxane, you might have to change it every several weeks. So it's a lot, it's a big expense. So what we have here is a picture of the Water Authority installed the first approved AOP system in service in the state of New York. Also the first full-scale pilot in the state of New York. And that was at our Commercial Boulevard facility in Central Islip. This well, it treats up to 1,000 gallons a minute. It removes 1,4-dioxane to non-detectable levels. And it does this with a combination of inside this reactor, there are ultraviolet lights, UV lights at a certain wavelength, and we introduce hydrogen peroxide to that as an oxidant. And the interchange, without getting too far into the weeds or chemistry lesson, which I never did very well in chemistry in college either. So there's a reaction between the hydrogen peroxide and that UV wavelength that creates hydroxyl radicals. And those hydroxyl radicals are very unstable things. And what they want to do most is they want to become part of a larger molecule. And they do that by breaking up molecules like 1,4-dioxane. And so they destroy it. About 70% of the peroxide that we inject does not get involved in the reaction. So it's a very inefficient process. And so what we do is we put a GAC system on the discharge side of that reactor, and the GAC system takes all that hydrogen peroxide out of the water before it goes into the distribution system. It also takes care of what's left of the byproducts of breaking up those 1,4-dioxane molecules. So when you think about an AOP system, it's this reactor, and then it's the GAC on the back end of it. That's a picture of a AOP building that we just did to house 2 AOP systems. This is on Douglas Avenue in Northport. This is a picture inside of that building. It's the new reactors that we're doing, and that's the GAC system in the background. And so the flow is coming out of the screen towards you, through the reactor, up and into the GAC system. Some of the other infrastructure projects that we've done in this area, in particular, Flower Hill Road, we have a set of boosters. These are kind of unique. Normally, a booster pump is used to increase pressure in an area. So we have what we call different pressure zones within the system that serve, because homes are at different elevations. So somebody who's at an elevation of 20 feet would not get served in the same zone as somebody who is sitting up at the top of a hill at 150 feet or 200 feet. And so we have a station that can serve both zones by using these booster pumps. Instead of putting them in a building, we actually came up with these, what we call can boosters, where the water will just come in. There's a pump sitting inside of that, just a regular submersible pump. And we're able to take it right out of the system and push it out without having to build a big building or anything like that around it. And also not have to worry about it freezing in the wintertime, which is nice. Other infrastructure projects are backup power, right? We want to make sure that we continue to have water supply, consistent water supply in the event of a power outage. So we have these generators. This one is at Mill Lane. And then we also have on the construction maintenance side that I spoke about, responsible for the distribution system. We have ways too that you can track online. You can take a look and you can see where water main breaks are occurring. So if you go to our website at scwa.com, you can click on this and you can see any active projects or water main breaks that are occurring in the area. And in terms of water mains, also the CM department did a job in Huntington Station earlier this spring. They did 1,600 feet of 12-inch replacement main. That was done on East 5th Street. And it ran east from Lenox for 1,600 feet. And what we did there was replaced 6 and 8-inch main, old undersized main, with 12-inch ductile iron main. So those are the types of things that we do. And with that, I'll hand it over to Ty Fuller. Thank you.
Hey, thanks, Tim. I want to first make a quick introduction. My name is Tyran Fuller. Most people know me as Ty Fuller. I've been with the authority for 22 years right now. My career actually started in engineering, where Tim is chief engineer. There, I started as a hydrogeologist. So starting there, I would oversee the construction, design, maintenance of our network of 600 plus wells. As my role expanded to Director of Strategic Initiatives, I work with the CEO on various projects. But what I want to focus on are some of the main initiatives I'm doing more recently. Aquifer sustainability. I work with the federal United States Geological Survey on those initiatives, overseeing developments, any developments that do come in. We review those projects to protect our aquifer. And as you can see from our discussion thus far, from what Jeff has explained, what the authority is, that we're not a branch in government, that the money that we generate through the sale of water is reinvested in this company for these various initiatives. Chris Niebling, him explaining the laboratory and the amount of testing that we do throughout our entire distribution system. Plus, with Tim explaining with engineering all the innovation that we do. We have a commitment to protect and preserve our water and supply the highest level that we can. So what I want to talk about is an initiative that I was involved in several years ago. One of the things that we realized is that there's a disconnect at times between what people receive throughout the news cycle. We hear a lot of stories about the issues with groundwater. What's the difference between groundwater and drinking water? There's a huge difference between that raw, untreated groundwater that we have versus the treated drinking water that meets federal and state standards that we supply. So several years ago, an organization was formed. It was in 2013, known as the Long Island Commission for Aquifer Protection. And what it was put together for was to have a consortium of people from various levels of government to work together to not only protect the quantity of the water that exists within an aquifer, but also the quality. Now, Tim's already explained that within the aquifer, you have a lot of potential threats that can occur within a public supply system that we have, whether it's homes, potentially cesspools or industry and all these different things. You have these scenarios that can occur locally. Like here, we have a lot of development, through industry, or maybe you're out east and you have farmlands. So depending on where you are, there are certain signatures that, you can experience. So you may have these local problems, but again, this is one aquifer. That's what we consider it. It's a sole source aquifer, and it's all connected. So these are island-wide issues that we need to be aware of. So anyway, several years ago, the various water suppliers on Long Island, they came together under this LICAP initiative that I spoke about. Now, you may not be aware of it, although with the Suffolk County Water Authority, we are one of about 50 different water districts on Long Island. Matter of fact, in this Huntington area, you have about 3 other water districts: South Huntington, Dix Hills, Greenlawn, right? They're their own little districts. But the thing is, the aquifer does not respect political boundaries, right? So one of the issues that we had historically was, how do we share this information, right? They're collecting their water information, we're collecting our water information, they're all speaking different languages. So several years ago, we worked together, we developed a platform where we could universally share our information from our different laboratories. We could present it so that we can visualize it, and we have all the water districts working together. And that initiative is known as WaterTalk. And with WaterTalk, it's available online. You can actually Google search it or go to our website, liaquifercommission.com. It says here LICAP online, but it's actually liaquifercommission.com right now. It's an online geographic-based water quality database. You can go in there, you can look at different wells, you can look at the raw, untreated groundwater, you can compare it with the treated drinking water that we provide to you. And that's the website right there. So anyway, this is a shot from the site itself. If you Google search WaterTalk, you can look it up. It'll give you a nice little description on what it does. You can go in there, you can put in your address, you can do a search in your area, you can look for different compounds, you can see what's in that groundwater, you can compare it to the treated drinking water. And I keep stressing those 2 points, right? Groundwater versus drinking water, because you need to understand that, with our drinking water, it goes through federal regulations, it goes through state regulations beyond what you see with bottled water. I mean, there is no more highly regulated thing that I know than groundwater, than drinking water, I should say. So please check out WaterTalk. You can learn a lot about your area. This is another screenshot of the program. And with that said, another thing that I just want to bring up before we go to questions is things that you can do, right? I mean, we spent this whole time talking about what we do. Again, this is an aquifer that we all use, and, we all play a role in protecting and preserving it. And one of the things that, we need to be aware of is what we can do to, conserve water. So Why should you conserve waters? Well, there's a couple of different things. You know, Long Island, we get our water from our aquifer. Yes, there's a lot of water down there. They estimate somewhere between 65 to 120 trillion gallons, give or take, but it's not limitless, right? You've seen in other areas of the country that they've had drought issues and all these different things. As a matter of fact, this summer, this August was the 4th driest summer August on record. For a long period of time, the state actually designated us as being in a severe drought. Currently, we're actually still in a moderate drought, but a couple of more of these rainstorms, we should be out of it. So it's not endless. Also, with the higher water usage, you know, again, if you use more water, it requires more infrastructure because it's going to require more wells to supply that, which those costs for those new wells or treatment systems get passed on to you in the form of higher rates. So we always want to avoid that. And then the biggest thing is that high water usage. Now, I don't know if you've experienced this here, but during the summertime, typically somewhere between midnight or 3 a.m. to 7 a.m., with all the sprinkler systems that are running, it can impact the pressure. We can only supply but so much water through these pipes. Eventually, our tanks start to drop in the levels. We start to lose water pressure. Our biggest concern is that there's a fire that occurs overnight, and then all of a sudden, we're not able to meet that pressure for the fire protection. So we want to make sure that, you know, we protect those things. And finally, overpumping can have negative water quality impacts. We are on an island. We're surrounded by seawater. If you pump too much, you can draw in seawater. That is a critical issue that we have, and we want to avoid that. So conservation is key. Now, what I'm showing here in this map is, you know, different scenarios. And I'm going to describe this really quickly. This is actually showing a 3-day period, right? This blue line right here is the winter time. And what it's showing here is about midnight to about 7 a.m. Now, what you can see is that overnight, very little water usage, right? It's the winter time right around now. You wake up around 7 o'clock, you go to work, you have some water usage. And then, you know, by 11 o'clock, drops off again, right? Compare that to the summertime, same period, somewhere between 6 a.m. What do you have? You see a 25-fold increase in water usage. Even during the rain that I'm showing right here, when it's raining during the summertime, people are still using water. Why is that? That is those automatic sprinkler systems that you set it and forget it. It's wasting a lot of water. It is a big problem for us. And that is what we call the irrigation situation. So what can you do? Changing some of your irrigation habits, that helps. If you have an irrigation timer, make sure it's not set between midnight and 7 a.m. Set it a little bit earlier, maybe a little bit afterwards. It's not a big deal. Another thing, use an odd even watering schedule. Grass likes to be stressed. If you give it some time to get stressed, it'll get deeper root growth. Should be all good. Very important, smart irrigation timer. Now, what's great about these things is that you can install this timer in the system. It connects to your local Wi-Fi, goes to your local weather system. If it's raining like it is right now, it'll automatically cut off, saving you money. So it's a great thing. And then the big thing is that if you do purchase one of these smart controllers, you can get a $50 credit on your SCWA bill just for purchasing that. What we've seen is people who do use these systems, they save up to 10% on their water bill on top of whatever credit they receive. So it's just a gift that keeps on giving. We also have a couple of programs that, you know, we hope you participate in. We have a program known as a WaterWise Checkup. It's a one-on-one consultation that we do. So we'll come to your house, we'll discuss what your water usage is. We'll come up with a specialized plan to help you save water. This actually works really well. We've reached out to people in Huntington before. And like I pointed out before, we have a WaterWise account credits, $50 off, purchase the water saving devices, whether it's low flow shower head, faucet aerator, smart controller. There's various different things. You can purchase those. Make sure it has the EPA WaterSense logo on there. Send us the receipt, you get a credit. And you can learn more about that on our website, scwa.com/waterwise. There's a telephone number there, email, all the details. But again, you can go right on our website. And finally, visit our website, Our Water, Our Lives. This is a united initiative that we have from different water suppliers, pushing conservation, giving you these various tips that I pointed out to you. Wonderful program that was developed through the LICAP initiative. We're really excited about what we've done, and hopefully you can work with us to protect the aquifer. And with that said, take questions.